This video discusses preemptive and non-preemptive process scheduling. A set of instructions stored on the hard disk is called a program. When an object of this program is created in the main memory of the computer, it is called a process. A process can have several attributes like ID, state, priority, etc. A state diagram shows how a newly created process enters the ready queue and gets executed over a period of time and finally gets terminated. So, CPU scheduling is a function of the operating system which is required when there are several processes which need to be executed in a certain amount of time. CPU scheduling maximizes CPU utilization and aims to make the system efficient, fast, and fair. So, when does CPU scheduling occur? CPU scheduling can occur when a running process encounters some input-output event and goes into the waiting state, or when a running process is interrupted by some system call and goes back into the ready queue, or when a waiting process has completed its input-output and goes back into the ready queue to get executed, or when a running process has completed its execution and gets finally terminated. So, CPU scheduling is of two types, preemptive and non-preemptive. Preemption is the act of interrupting a running process with the intention of resuming it at a later time. This interrupt is caused by an external scheduler, which is a part of the operating system with no assistance from the process. Let us first learn about non-preemptive or cooperative scheduling. In this scheduling, once the CPU has been allocated to a process, it will hold the CPU until it gets terminated or until it switches its state to waiting. Now, as the name suggests, this type of scheduling does not cause any interrupt during the execution of a running process. Instead, the CPU is allocated to the next process in the ready queue only once the currently running process has completed its CPU burst time. What is the CPU burst time? It is the total time required by a process to complete its execution. Consider the following example with 5 processes. We can use the first come first serve non-preemptive algorithm to make a Gantt chart for the following example. The Gantt chart looks like this. So we have the first process P1 being executed for a total time period of 10 milliseconds, and once it gets terminated, the CPU will be allocated to the next process which will run for a period of 2 milliseconds and gets terminated, and once this gets terminated, the next process in the queue, which is P3, will run for another 7 milliseconds, that is up till the 19th second, and get terminated, and so on and so forth. And this process continues until all the processes in the ready queue are over. You might notice that this kind of scheduling algorithm does not require any special hardware like a timer and can be used on platforms which have very specific requirements. However, starvation can occur to processes with burst time lower than that of the running process, and as a result, CPU resources might not get allocated to these processes. Now, algorithms which are based on non-preemptive scheduling include shortest job first, longest job first, first come first serve, and priority scheduling. Moving further, in preemptive scheduling, the operating system allocates the resources to a process for a limited time period, and this time period is calculated on the basis of various criteria depending on the algorithm being implemented. So once this time period gets over and the process still has some burst time left, then it will be placed back into the ready queue and the next process will be allowed to execute. Consider the round robin scheduling algorithm. In this, a timer causes an interrupt when the time quantum or the time slice allocated to the process is over and the resources will be allocated to the next process. In this example, we have 3 processes with the following burst time, and a time quantum of 3 milliseconds is uh, chosen. So in the Gantt chart, we can see that the first process executed for a period of 3 milliseconds, and even though its burst time is still left, that is 7 minus 3, 4 milliseconds are still left, the next process in the ready queue, P2, will get executed. This process got terminated after 3 milliseconds, and on the 6th second, we have P3. P3 will run for 3 milliseconds, will go back into the ready queue, and P1 gets a chance to perform its operation. And once again, we notice that we have another 1 millisecond left for the termination of P1. And we notice that this algorithm keeps switching between the processes until the termination of each of the processes occurs. The algorithms based on preemptive scheduling include SRTF, LRTF, round robin, FCFS, priority scheduling in the preemptive mode, etc. So we notice that starvation can occur in preemptive scheduling also. For example, in priority scheduling, if higher priority processes keep entering the ready queue frequently, starvation will occur to lower priority processes as the CPU keeps switching between these processes. Also, these interrupts are unintended, and as a result, the design of the operating system kernel gets affected in preemption. And also, there is a cost associated with shared data access. Comparing preemptive and non-preemptive scheduling, we notice resources are allocated to a process for some calculated time in preemptive one, and in non-preemptive, we have resources allocated to a running process until it gets terminated or goes into waiting. So the processes in preemptive scheduling will be interrupted unintendedly, and in non-preemptive there are no such interruptions. Starvation occurs in both of them, and there are overheads in preemptive scheduling. For example, you require a timer, and there are also costs associated with shared data. In non-preemptive scheduling, there are no overheads and no special hardware requirement. As a result, preemptive scheduling is flexible and non-preemptive scheduling is rigid. There is high CPU utilization in preemptive scheduling, and there is comparatively lesser CPU utilization in non-preemptive. Non-preemptive scheduling has been available since up till Windows 95 in Microsoft, and preemptive scheduling was introduced later on in both Macintosh and Microsoft. Thanks for listening.